Hey guys, I hope you're having a great day. I just wanted to go through our lesson that you're going to put into your notebooks today. So please make sure that you reference your haiku page for instructions on what page these should be in your notebook. We're going to start with our learning target for today. And our learning target for today looks like this. I can describe the solution set for a given inequality. So if you need to pause the video right here to write down your learning target, please do so. The title of today's page is Solution Sets. I want us to start by looking at the phrase solution set. So you probably already know that the word solution is a fancy word for the answer, and a set is a group of items. So a solution set is the group of answers that can make an inequality true. So again, feel free to pause the video anytime you need to write this information down. So I want us to kind of take a step back and revisit like what you did in elementary school, because you guys know that when you were first introduced to inequalities, they were introduced to you something like this. So you might have had ones that look like this, where it would be like 2 is what in comparison with 5. And you would have said, oh, okay, well 2 has a smaller value than 5, so 2 is less than 5. And then you may have had some that look like this, where they were missing a number and it wanted you to do this. And so you had to choose a number that would make this inequality true. So you would choose any number that would fit into this bubble that would be bigger or greater than 7. So that number could be a 9, that number could be a 10, that number could be a 7.5, that number could be a 2,612. As long as the number was larger than 7, it makes the inequality true. So keep that in mind as we work through today's lesson. I do want us to review what we've been working on in class. So as a review, we're just going to revisit what we've been doing. So we talked about how to solve inequalities. So if I have this inequality, x plus 2 is greater than or equal to 5. Now remember that these are very similar to solving equations, except that instead of having just one answer, we have a series of answers that could possibly fit into the x, or the unknown. So we solve this exactly like we solved an equation. We do the inverse. So this problem says some number plus 2. So we're going to subtract 2, just like we did with the equations. We're going to undo or do the inverse operation. We're going to undo this as well. A plus 2 and a minus 2, we know, cancel each other out, and I'm left with just a variable x. My sign doesn't change, it doesn't flip for this one. And I do 5 minus 2. 5 minus 2 is, of course, 3. So what this tells me is that my number that could go in here for x could be any number that is equal to 3, so that would be a 3, or it could be any number that is greater than a 3. So any number greater than 3 or exactly 3 would work for this particular unknown. So today we're looking at something called solution sets, which, as we discussed at the beginning of the lesson, means a group of answers that could make an inequality true. So let me show you what this looks like. I want you to copy down this example. This says a number minus 5 is less than or equal to 26. A number minus 5 is less than or equal to 26. So if I wanted to figure out what this is, I'm going to solve it just like I would solve it if it were an equation. So I'm going to do the inverse of minus 5, which if you're thinking along with me, you know that the inverse is a plus 5. So I'm going to add 5. And this minus 5 and this plus 5, they cancel each other out. And I'm left with an n. I don't flip my sign. I do 26 plus 5, which is 31. So basically, any number that is smaller than 31 or equal to 31 would make this work. So here's how you write your solution set. It can be any number from 31 or lower. So I'm going to start here and write 31 because that's the biggest number that this n could be. The next number it could be would be 30. And then it could be a 29 if I wanted it to, or it could be a 28. And actually, this one could go on and on and on forever. So if you see I put 3 little dots right there, you might know that whenever you see those, that means and so on and so on. So actually, any number that would fall way down here on this number line could make this happen. If you think about this on a number line, it could be any number. If I asked you to graph this, you would put a circle around 31 and you would color it in, and then you would color in any number that were to the left of that. So do you see how these are any numbers to the left of that? If you want to be really technical, it could be any number 31 or lower. So it could be 30.9, 30.8, 30.7. But this is a really good representation of the solution set for that inequality. Let's do another one. We're going to do several examples together. So this one is 2n is greater than 6.8. So jot that one down. We're going to do it together. This means 2 times a number. So if I want to get rid of 2 times a number, I am going to do divided by 2. Okay, so that leaves me with n. I don't flip my sign. And if you do 6.8 divided by 2, if you want to do it over here with me, you can. Of course, you're getting to use your calculator, but if you didn't have a calculator, you could do this. Put our decimal in place. That goes in 3 times. And that goes in 4 times. So my answer here is 3.4. So this says that n could be anything greater than 3.4. Now notice it can't be 3.4 this time. It could be anything greater than 3.4. So there's a couple of different solution sets you could write. We always do the little open brackets, looks like a little squiggly line. The first number that it could be would be like 3.41 because it can't be exactly 3.4, but it could be 3.41. And if you don't believe me and you want to test it, you could always plug it in on your calculator. So you could do 3.41 times 2, which is what the original problem said. And 3.41 is 6.82. Well, if you compare 6.82 to 6.8, 6.82 is a little bit bigger. So that does make that inequality true. The next one, of course, if you're going to go this route, would be 3.42 and then 3.43. And then that one would continue on and on and on. So I put the 3 little dots there to show that that pattern would just continue to repeat. If you don't want to do those funny decimals, you could just start with 3.5. Because if it's not 3.4, then the next whole number decimal would be 3.5. Then 3.6, then 3.7, and so on. So you get the point that it could be either one of those. Luckily for you, you're going to see it in the form of multiple choice, probably, so you can just figure out which one they're actually looking for. Let's do a couple more. So the next one we're going to do is 1/3 x is greater than or equal to 3. Now this means 1/3 times a number. So to undo this, I'm going to divide by 1/3. And if I divide 1/3 by 1/3, of course those go away. And I'm just left with an x. I don't flip my sign here. And then 3 divided by 1/3, if you're doing it along with me, you're getting a 9. So that means that my number whatever x is, has to be greater than or equal to 9. So my solution set, for those of you who haven't figured it out yet, is going to look something like this. 9 is the smallest number that it can be. It has to be greater than that. So the next one could be 10, 11, 12. You get the point. We go on and on and on. Any number that's 9 or bigger, think about it like a number line, would be the solution set for this. One more example and then we'll do some challenge questions. So this last example looks like this. N plus 2 is less than, nope, I'm sorry. Pause that. Let's do a harder one. N plus 3.2 is less than 6. So if I wish to solve this one, I'm going to do minus 3.2, the inverse of plus 3.2. And here's your worst nightmare. We have some decimals to work with. So if you don't have a calculator, you can still do this. The plus 3.2 and the minus 3.2 cancel each other out. And I'm left with an n. I do not change my sign. There is an imaginary 0 here, as you might remember. Can't do that, so I'm going to borrow. Of course, you've got a calculator, guys, so you can use your calculator. 10 minus 2 is 8. 5 minus 3 is 2. So my numbers have to be less than 2.8. Can't be equal, have to be less than. So 2.8 is the biggest that it can be. So you got a couple of different options here. You could start with 2.7. Now notice that's the biggest number, so I've got to write it over here. And then 2.6, and then 2.5, and then this pattern would continue in this direction. If you want to, you could start with 2.79, because that would be the smallest number, right? And then 2.78, and then 2.76. So either of those patterns of numbers would work. So here's how it gets really interesting. So these are actually challenge questions. And you really just have to think about these. So if I have 2 is less than n is less than or equal to 6. Well, that means that n is a number that is somewhere bigger than 2, so larger than 2. This is what this means, right? Because n is greater than 2. Can't be equal, has to be greater than. But it has to be smaller than or equal to 6. That's what that says. So greater than 2. So the first number that I think of that's greater than 2 would be 3. But it has to be smaller than or equal to 6. So can I do 4? Absolutely. 4 would work in there because 4 is bigger than 2, but smaller than or equal to 6. Can I do 5? Absolutely. Plug it in. Does it work? 5 is, of course, bigger than 2. Is it less than 6? Yes, it is. How about 6? Can I do 6? Well, if I plug 6 in here, 6 is, of course, greater than 2. And it is less than, no, it's not, but it's equal to 6. So that means I can use 6. Now, can I do a 7? If I do a 7 in there, 7 works for this part. It's greater than 2, but 7 is not less than 6. So I cannot do 7. So that means that this solution set has a close. Notice that this one doesn't have the little ellipses or the 3 little dots that mean it goes on and on, because this one doesn't actually go on and on. You're limited to where that number can actually be on a number line. So I hope that this video has helped you. Feel free to go back and watch it again if you need to. And again, please check your Haiku page to make sure that you have entered this information onto the correct page of your notebook. Thanks.